Hello everyone. In this video, we conclude our discussion of section 5.6 by discussing how to graph both tangent and cotangent functions. So we'll start with tangent. If you'll remember from a few videos ago, I can't remember exactly how many, but I talked about how the period of tangent, the normal tangent graph, like y equals tangent of x, is not 2 pi, unlike all the other like sine, cosecant, cosine, and secant. Those all have base period 2 pi, whereas tangent and cotangent have base period pi. And so you'll notice to find the period of a tangent graph, you take, instead of 2 pi, you take just pi divided by the absolute value of the number in front of x. So that's something you'll need to remember as being slightly different. The increment, of course, is still going to be the period divided by 4, nothing surprising there. But now you'll notice we're not concerning ourselves with an amplitude or a phase shift or anything like that, because at least the phase shifting will kind of be captured in this expression that we're going to discover right here. So what we find instead is successive vertical asymptotes. And for the tangent, you have successive vertical asymptotes between minus pi over 2 and pi over 2. And what you put in the middle here is the inside part of the tangent. So you'll always start with this, and then you will solve this for x. And we'll do, if you haven't worked with solving multiple inequalities like this, we'll do that when we work our examples here, and we'll see how it works. Okay, so first let's find the period of this first example here. Well, we just take pi divided by the absolute value of the number in front of x, and that number is 1/3. The absolute value doesn't do anything, so you just get 3 pi. And then the increment, that should be familiar, just divide it by 4, right? Now to find our successive vertical asymptotes, we're going to take minus pi over 2 less than 1/3 x minus pi over 3, and then less than pi over 2. And now we're going to solve this for x. So what you're going to do is first, behave as if these were equal signs. So first thing you're going to do is add pi over 3, and now instead of to both sides, you add it to all 3 parts, right? So what you get is minus pi over 2 plus pi over 3 less than 1/3 x less than pi over 2 plus pi over 3, right? And pi over 2 plus pi over 3 is 5 pi over 6, and this here will be minus pi over 6. So what we get is minus pi over 6 less than 1/3 x less than 5 pi over 6. And now, just how would you solve for x? Well, you would multiply, quote unquote, both sides by 3, right? Well, now just do that to all 3 parts. So multiplying all 3 parts by 3, you get minus pi over 2 less than x less than 5 pi over 2. And the thing I want to make clear here is the only time that you would flip the inequalities is if you're multiplying or dividing by a negative. But 1/3 is positive, and we're multiplying by 3, which is also positive. So the inequalities are preserved, as we say. All right, and now these are strict inequalities here, and we'll see why in just a second. Okay, so what we're going to do now is we're going to start with that number on the left, which is minus pi over 2, and now we're just going to increment until we get to the number on the right. So the very last thing I have down here will be 5 pi over 2. And so I should have 3 values in between. Well, let's see. Minus pi over 2 plus 3 pi over 4 is 1 pi over 4. And now I add 3 pi over 4 to that, and I get pi. And I add 3 pi over 4 to that, and I get 7 pi over 4. And now if I add 3 pi over 4 to that, I get 10 pi over 4, which is the same as 5 pi over 2. So it actually worked, right? Okay, so now the numbers on the end for tangent and then also for cotangent, they actually don't have an associated value. You have a vertical asymptote there with no value. But the 3 in the middle, let's compute them. So we get 3 tangent 1/3 times pi over 4 minus pi over 3. Well, this is 3 times the tangent. And now I'm switching minus pi over 3 to the common denominator 12, so I get minus 4 pi over 12, which is 3 tangent minus 3 pi over 12. And this number is 3 tangent minus pi over 4. And the tangent of pi over 4 is 1. And since tangent is odd, I get the tangent of negative pi over 4 is negative 1 times 3 is negative 3. Okay, now let's plug in pi. Oh, this is easy. Notice you just get pi over 3 minus pi over 3 inside the tangent. So that's 3 tan of 0, which is, you guessed it, 0. And here I get 3 tangent 1/3 times 7 pi over 4 minus pi over 3. And I'm going to do the same thing as the first part. And I get technically 3 tangent 3 pi over 12, which simplifies to 3 tangent pi over 4. Tangent pi over 4 is 1, so I get 3 times 1, which is 3. Okay, so at minus pi over 2, which I'm going to say is like right here, I have an asymptote. And at pi over 4, let's say is right here, I get a value of minus 3, which I'll say is down here. At pi, I have a value of 0. Then at 7 pi over 4, I have a value of 3. And then at 5 pi over 2, I have another asymptote. Okay, it's not perfect, but so it is. Now the way the tangent works is it kind of snakes between these 3 values. So, and it goes towards the asymptote in either direction. So here, it kind of goes like this. Just snake your way through these values. And now, here's the asymptote here. So it kind of goes like that. All right, and now it's time to graph cotangent. It's going to feel somewhat similar. The period is still pi divided by the absolute value of the number in front of x, which we call b. The increment is the period divided by 4. And to find successive vertical asymptotes, though, you have to instead use 0 less than bx plus c less than pi. So instead of the minus pi over 2 and pi over 2, you put 0 and pi on the outside. But otherwise, it's going to work pretty much the same. So the period here is pi divided by the absolute value of 3, which is pi over 3. Increment is take that and divide by 4, which is pi over 12. And to find successive vertical asymptotes, we put 3x minus pi in between 0 and pi. Now we're going to add pi, so we get pi less than 3x less than 2 pi, and then divide everything by 3, which is positive. So we preserve essentially the direction of the inequalities. So the first number I get here is the one on the left, pi over 3. The last one down here will be 2 pi over 3. And to get the 3 intermediate ones, I just start at pi over 3 and increment by pi over 12. So the next one will be 5 pi over 12. Then 6 pi over 12, which is technically pi over 2. And then 7 pi over 12. And now the next one would be 8 pi over 12, which is indeed 2 pi over 3. So for the same as with tangent, for cotangent, the first and last don't have an associated value. Those are asymptotes. But then in the middle here, let's see, what do we got? We got 1/3 cotangent 3 times 5 pi over 12 minus pi. So that's 15 pi over 12 And now I'm going to write pi as 12 pi over 12. And so that's 1/3 cotangent. 3 pi over 12 is the same as pi over 4. And the nice thing about cotangent is that since we know tangent of pi over 4 is 1, the cotangent is just the reciprocal, which is also 1. Okay. Then pi over 2, I'm not going to go through the work. I'll just kind of speed through it here. You plug in pi over 2, and you'll actually get 0 out of this. So check your chart. Oh, I'm sorry. There should be a cotangent here. 1/3 cotangent of 3 times pi over 2 minus pi. And then here, the value you're going to get is minus 1/3. And so pi over 3, let's say, is right here. Then the next one is 5 pi over 12. This is probably not to scale, but what are you going to do? Pi over 2, 7 pi over 12, and 2 pi over 3. Okay, so at pi over 3, which is the left end, and 2 pi over 3, which is the right end, we have asymptotes. 5 pi over 12, I get a value of 1/3, then 0, and then minus 1/3. And once again, the graph kind of snakes in between. I'm not claiming to be an artist, by the way. So it should kind of like jog in the middle a little bit. I'm not great at drawing it. I think this was probably a better picture of the tangent there, how that kind of jogs in the middle. Like this isn't a straight line, so to speak. It's a kind of nice curved line there. But okay, that should help you with the worksheet then. In the next video, we're going to hop all the way ahead to section 6.2.